Hello, my name is Alexander Koval. I'm Associate Professor from Department of Biological Chemistry of Gomel State Medical University, Belarus. Today I want to explain you how to calculate peptide charges by interval method. So let's start it. So let's remember, what is the interval method? From our high school algebra course, you remember the basic of functional analysis. For example, we can see the function y is equal to x squared minus 1. The value of this function is positive from minus infinity to minus 1 and from 1 to plus infinity. And in the range of minus 1 to 1 it's negative, and in the points of minus 1 and 1 the value of this function is 0. These are extrema or critical points. They change the sign of the function. We will use this approach to analyze the charge of peptide over the entire range of pH from 0 to 14. In our calculation, we will be guided by the values of pKa from the table. pKa, the indicator of the acid dissociation constant, plays the role of critical points. Here we can see positively charged and negatively charged amino acids and the corresponding pKa value for these radicals and structures. So we shall try to remember this structure to analyze the total charge of the peptide. Let's consider three possible cases. Amino acids are present in the peptide which, first, do not carry a charge. They are not in the pKa table we have just seen. Second moment, they carry a charge, so these 9 amino acids in the pKa table are present. And the third, we can analyze the intermediate option. We shall draw the peptide formulas with the chemical editor ACD Chem Sketch. This is a freeware program for educational use. First peptide we shall analyze is VIGLA, which consists of valine, isoleucine, glycine, leucine and alanine. So we can read this peptide like valine, isoleucine, glycine, leucine and alanine. So all amino acids are aliphatic nonpolar, hence the radical cannot be charged. Only terminal alpha groups can be charged. These are amino group minus with pKa 9.0 and COOH with pKa 2.5. So calculation of this peptide, pentapeptide charges, it looks like this. This case is the simplest. The radical of these amino acids are not involved in the charge formation. So we can draw only 2 points on the segment 2.5 and 9. So this is our pH range from 0 to 14, and we place these two values for carboxyl group 2.5 and for amino group 2.0. In a strongly acidic medium left range, the maximum positive charge is plus from NH2 group. In a strongly alkaline environment right range, the charge is maximally negative due to COO minus group. In the intermediate interval, the charge is neutral because plus and minus are neutralized. Next case is the most difficult. Nonpeptide, which can be read as histidyl, lysyl, arginyl, aspartyl, glutamyl, cysteine, tyrosyl, threonyl, serine. So these amino acid radicals can be either basic positively charged like histidine, lysine, arginine with corresponding pKa values, and acidic negatively charged aspartate, glutamate, cysteine, tyrosine, threonine and serine. Also do not forget about the N group NH2 and COOH. So we can see half of this peptide is composed of basic radicals of amino acid. Another part of this peptide is composed of acidic, negatively charged amino acid radicals. How to calculate the charges for this nonpeptide? We can use our template we have discussed before. Analyze amino acid and mark the point for the corresponding pKa. First we shall draw the range from 0 to 14 pH and place the values for NH2 group and COOH group 2.5, 9.0 and 2.5 correspondingly. Then we shall analyze. First amino acid histidine. So we place its value 6.5. Next amino acid is lysine. 10.5 is added to our range. And so on. Arginine 12.5. So we can see 4 positively charged structures in this peptide. We continue our analysis. Aspartate 3.9, glutamine 4.1, cysteine 8.2, tyrosine 10.1, threonine 13.3 and serine 13.4. So these 7 structures will be charged negatively. So it will help us to calculate the total charge of the peptide. So all these 11 points will make 12 intervals. So now let's see the charges in the extreme left interval, in the most acidic pH from 0 to 2.5. So because the number of positively charged amino acids is 4, so the maximal positive charge will be 4. Now let's analyze the extreme right interval in the most basic region. So we can calculate the number of negatively charged radicals and structures will be 7, and the maximal negative charge will be 7 minus. And all other, the rest of the charges are filled with a decrement of -1. We have solved this difficult task. So let's go to the next example. Tetrapeptide aspartyl-phenylalanine histidyl-lysine. So this is an example of intermediate difficulty. All amino acids except phenylalanine are charged. Basic amino acids are histidine and lysine. Acidic aspartate. Do not forget about the end groups NH2 and COOH. These points, pH, pKa values 9.0 and 2.5 will be added to our range by default. Now the calculation of these tetrapeptide charges. Let's apply our template as a line segment with the end 0 and 14 and the entire pH range with point 2.5 and 9.0. So if any amino acid is found in the table mentioned before, indicate pKa on a straight line. If not, for example, phenylalanine, skip it. So let's analyze. Aspartate 3.9, it will be charged. Phenylalanine. This amino acid radical cannot be charged, so we skip it. Next, histidine 6.5 will be added to our range. And finally, lysine 10.5. So these 5 points make us 6 intervals. In the extreme left interval, strongly acid environment, the peptide charge is maximally positive, 3+. We can see 3 positively charged structures which are marked with blue color. In the extreme right interval, strong alkaline medium, the maximum negative charge of the peptide is 2- because only 2 negatively charged structures are present in our peptide. So we can see the beginning and the end of the intervals, and all the rest interval we will fill by decrement 1. So we can see 3 plus, 2 plus, 1 plus, 0, 1 minus, 2 minus. Now we have fulfilled also this task. So application of this method can be: the charge of protein and peptide is important in the interaction of a protein and a ligand, like enzymes, antibodies, histones, etc. In the digestion of protein, the role of the pH gradient of the juices of various parts of gastrointestinal tract is very important. The difference in the charge of peptide are used when separating a mixture of peptide by electrophoresis, determining the direction and speed of movement of peptides in an electric field, also selection of the optimal pH of the buffer for separating the mixture of peptides. Thank you for your attention. I hope you enjoyed this explanation. Please subscribe to our YouTube channels, Draw Biochemistry and Biochemistry GSMU.